Okay. Section 6.2, construct a confidence interval, the population mean, where sigma is unknown and the sample standard deviation is given instead. We use Z in section 6.1 because sigma is known. We have the standard normal distribution. It's based on the fact that we know the population standard deviation. If the population standard deviation is not known, we're going to use a different distribution called T distribution. And I'm going to show you, just sketch this distribution and show you the difference between the Z distribution and the T distribution. Here is the Z distribution, guys, that you learned about already and you've been using for a while. This is Z. This is 0. That's a 1. That's a 2. That's a 3 here. -1, -2, -3. This is the Z distribution, the normal distribution. Area under the curve, guys, is 1. But let me show you how the T distribution looks like. It's a family of curves, actually. I wonder if a student can tell me, what do you see? This is always 0, 1, 2, 3, -1, -2, -3. And those curves change with the sample size, guys. What do you notice if you look at the right and the left of each curve? Anything that you notice? That's a T. Look here and look there. What is it that you notice, guys, here? Let's see.
The same.
Oh, the mean is the same, yes. That is true. That's a Z and T, but what's the difference between the two? Look here and look there. What do you notice the difference is? This one almost touches the horizontal line, but those families of curves seem, just to have a thicker tail and they don't touch the horizontal line. So that's one difference between the two distributions. I'm going to show you a visual from the book about the T distribution to have a better feel of that. Let me show. Okay. Look, guys. Look at the blue one is the standard normal curve. It's almost touching the axis, but it doesn't touch. But look, at the T curves. They don't seem, just to touch, and they have a thicker tails. Let me tell you what the df equals 5 means, just for now. df equals 5 means the sample size is a 5 plus 1. So that's a sample size of 6. 2, just add 1 to it. That's a sample size of 3. And the larger the sample size, guys, the closer the T distribution become to the Z distribution. When you do a Z distribution, the sample size will be 30 or more. So the larger the sample size, the closer the line will become, just to the curve, and the thinner the tail. You can see now the tail, just is very thick. But as you increase sample size, it will become just like the normal curve and almost touch, but it will never touch. So the T distribution, guys, very much the same as the Z distribution. Mean, median, and mode are the same. The T distribution is bell-shaped and symmetric. I'm reading right here. The total area under the t distribution is 1, just like the z distribution. Here's the difference here. The tails in the t distribution are thicker than those in the standard normal distribution. And instead of using sample size, we use degrees of freedom. And degrees of freedom means sample size minus 1. So anytime, guys, you see a curve with a df equals 5, it means the sample size was 6. A df equals 9, the sample size was 10. And as the degrees of freedom increase, the t distribution approached the z distribution, as shown in the figure, as you can see that. So this is what we're going to be using to find confidence interval for the mean when sigma is unknown. Now the question, guys, probably you want to ask me, how do we know if sigma is known or unknown? Here's how you can tell, guys. If he tells you, assume that the population standard deviation is known, that means he gave you sigma. Then you cannot use a t distribution, you must use a z distribution. But if he says the sample standard deviation is, that means he's giving you S. So a sigma is a z distribution, and an S, we use what we call a t distribution. And you're going to see, guys, I'm going to do some practice exercises that you'll be able to distinguish between the two. And let me show you what formula we're going to be using to construct confidence intervals. It's going to be pretty much the same, just like section 6.1. And watch me make it some slight changes, guys. And then we'll go and do some exercises. Here's what we learned in section 6.1. I'm going to build on that. Mu is between x bar minus e and x bar plus e. And the e, what was e in the previous section? We're going to make some changes to this formula and we'll make it work in this section. Okay, I'm going to ask you guys to help me out. If I change sigma to something else, because we don't know sigma in section 6.2, what would you put instead?
S.
S, very good. And if I change the letter Z in this section to, because I don't know about the Z distribution, I'm not using the Z distribution, what letter would you use, guys? Z, and what was this here?
T.
T, it will be T. And here's your formula, guys. Nothing changes. And again, guys, you will be given this. You will be given S. You will be given N, and I'm going to show you how to find T based on the confidence level. And actually find T, it's going to be very easy using the table instead of using the calculator, just like we did inverse norm. So let me show. That's pretty much it. And if I go back to a different table to do this, we're not going to be using this table because this table has a Z in it, guys. That's for section 6.1. So there must be a table for T. And let me show you the table for T. It's already given to you. This table is going to pop up in every single question you do in section 6.2. Watch, guys, how to use this table. And there is no way that you can get confused. It says T distribution. So that's for T. You put a note for yourself that I will be using the T distribution when sigma is unknown. So, and the sample standard deviation is given. So if I say construct a 90% confidence interval and the sample size is 10, let me show you guys how to find, just this TC value. You look at the 90% confidence right here. It's right here. And if your sample size is 10, the degrees of freedom will be 10 minus 1. So you look it up here, which is 9. And guys, you just go horizontally and vertically. 90 until you get 9. That will be your critical value, which is 1.833.
Did you say it's always -1?
What is it?
Did you say it's always -1?
Always -1. Yeah, that's the formula for the degrees of freedom. So degrees of freedom is n minus 1. If your sample size is 15, you look for 14. If your sample size is 25, you look for 24. And look, there is a 24 here. And look, it takes you all the way to infinity. Now, if your sample size is 100, you look for 99, but there is no 99, so you just use 100 because that's the closest to 99. If your sample size is 40, guys, you use 39. Look, 39 is already there. But usually sample size when we use t-distribution are small. So most likely, guys, you'll end up using, just the top part of the table to find TC. So we use, just this table to find the value of TC, the critical value, which is called TC. I'm going to show you guys an example and how to do this. And yes, we can use the calculator with this as well. All right. Ready? So that's the first example. You wish to estimate the average number of housing starts in all large cities in the United States. You have a random sample of 25 cities, so that's N. And obtain the number of housing starts in each. The sample mean, X bar, is 525. With a sample standard deviation, do you read it, guys, carefully? It says sample standard deviation. Don't make it sigma, it's S. Construct a 95% confidence interval. We need a confidence interval. Okay, let's do it. Let me see if I left a room for this on the other page. If not, I'll just do it on the same page. Yeah, actually, I did. So, all right. So, S, guys, is we said it's 40. X bar is 525. And the sample size, N, is 25. And he wants the confidence level to be 95%. All right. We said this is the formula for E. It's TC S over square root of N. And watch, guys. Let's find T. Confidence level is 95%, and the sample size is 24. We need the degrees of freedom, which is going to be 25 minus 1, which is 24. And let me take you to the table. You guys can help me, first of all, find TC. That's the most challenging part, and everything else is just computation.
That's a good question. Are you doing that on page 5? Because did you miss page 4?
Let me see. Hold on a second.
2.064.
2.064. Let's see. That is correct. 2.064. That's it. That's all I need. So TC is 2.064. To find E, guys, it is TC times S divided by square root of N, which is 2.064 times S, which is 40, divided by square root of N, which is square root of 25. And I've done the work, as you can see here, guys, already. So it will be 16.512. And now your interval, guys, is X bar minus E and X bar plus E. So you just do mean between. X bar is 525. and then you minus the 16.51, and then 525 plus the 16.51, and you will get the values 508 and 541.5. And to write a conclusion, guys, you can say with 95% confidence, we can say that the true mean number of housing starts in all cities of interest is between 508.5 and 541.5. That is
I have
how
a
you.
question. In your
Yes.
sample you typed out, it says the 525 plus minus the 2.064 times 8.
Oh, 8 is 40 divided by square root of 25.
Oh, okay, sorry. Thank you.
Yeah, square root of 25 is 5. That's a good question. I know it's confusing, but I just did this. 40 divided by 5 is 8, and I put it there. This is a shortcut. Probably I shouldn't have done it this way, but just I wanted to show you how you can do this with a shortcut. I prefer that you do it, just that way, and just do the calculation, which we're gonna do in the next one. So example 2, guys. I have a lot of space for this one. And let me show you guys that you would like to see how the calculator is used here. Watch. Turn the calculator on, clear, stat. From now on, guys, it's just gonna be stat and then tests. Everything, almost everything from now till the end of the semester. Most of the stuff we'll be doing right there. Okay. Can someone tell me which feature we're going to be using? It's not going to be 7. And let me tell you why it's not 7, because sigma is not known. If you tell me where students struggle with this chapter, I can tell you easily, guys. They get confused between 7 and 8. 7 is used only if the population standard deviation sigma is given in the problem. 8 is used when S is given instead of sigma. So in section 6.2, guys, you will be using 8 all the way. And tell me why 8. Look at the hint. It says T interval, not a Z interval. And watch, when I go to 8, it's not going to ask you for sigma. It's going to ask you for S. Watch. You see what it says S? It doesn't say sigma anymore. So X bar, 525. S, what was it? 40. N is 25. Confidence level, 95. Hit calculate. There you go, guys. 508.45 and 541.51. It's the same interval that we did by hand. Example 2. Construct a 95% confidence interval for the population mean. Do you see the question? Very much the same. Construct an interval. Assume that the population has normal distribution, bell-shaped. A sample of 20 part-time workers. So N is 20. Trying to walk you through the stuff. Look, I ask you to list the given values. N is 20. Had a mean annual earnings of 3,120. That's X bar. Now, sometimes the students, by mistake, they put a mu here. We don't know the actual mean. He's telling me an information from the sample. He says the sample of 20 people give me a mean of 3,120. So that's X bar. We don't know that what the mean is. Sample standard deviation, guys, is S 677. And confidence level is construct what? 95%. There's no way that you can go wrong here if you label those numbers correctly, guys, because you're going to enter them correctly into the calculator. Okay, I'm going to do this by hand and using the calculator. So let's do it by hand first. Find the critical value TC using table 5. Okay, help me out, guys. So if N is 20, what's the degrees of freedom? It will be what? 19, and confidence is 95. There you go. touch. 95, and I need 19. There you go, guys. It's 2.093. And now let's put it in the formula. 2.093 times S, which is $600.77, divided by square root of 20. And let's do the math here. 2.093 times $600.77, and then divide by, you can do it all in one shot. Look, how do you do square root, guys? That's the algebra that you need to be aware of. Second, x squared, and put 20 in there. To get out of the square root, guys, use the arrow key. 316.84. And watch, guys, the mean is between. You're done. X bar is 3,120 minus 316.84, and 3,120 plus 316.84. Mean will be, just do the subtraction and you're all set. 3,120.00 minus 316.84. I get, guys, 2,803.16. And the other one will be 3,436.84. And interpret your answer in words with. Okay, now I want the students to help me interpret the answer. With what? This.
95%.
95% confidence. We can say that the true mean annual earnings, look, copy it from here, is between the two values that you came up with. Now, guys, if you're doing it online and he doesn't ask you to show the work, you can simply just use the TI-84, which is, I'm going to show you how to do it in a second. Using TI-84. Go to Stat, Tests, T interval, input, you use stats. I'm going to show you all the keys. You enter the value of X bar, you enter the value of N, you have entered the value of S, you enter the confidence level, you enter S, which is 677, you enter N, which is 20, not 19. You use 19 only for the table, but you just put the sample size here, whatever it is. 3120, and let's do it. Stat. I cannot make it any easier, guys, using the calculator. Look how easy it is. If you just use the right formula. So X bar 3120, S is 677, N is 20, confidence level is 95, and hit calculate, and here you go. And you can see, guys, it's a match with what? Oh, it did one decimal, but I have two decimal, 0.16. If I round it, it will be 0.2, and if I round this one, it will be 0.8. So that is the confidence interval. All right. There is another one. which is really an interesting one. It really, guys, show you how to use confidence intervals in real life. It's a good application of confidence. You go to second, distribute. Inverse norm is to find ZC. Can you guess, guys, what would be the function to find TC? It's obvious. It's on the screen. Any guesses? The next one, it says inverse T. The first one, 3, it's inverse norm. You need the area to the left, comma 0, comma 1. For inverse T, you need two things, the area to the left of the target and then the degrees of freedom. So let me show you how you could use this. But it's actually, guys, it's very easy to use the table, easier than using even the formula on the calculator. So let me just give you an example. Let's say confidence level is 95% and N is 17. Let me show you how to use the calculator to find TC. First of all, degrees of freedom will be what? 16. So this is the second value. Now, what's the area? The area, you just do the same work as you do for ZC. You do 100% because there are two tails, minus 95%, which is a 5%, and take the 5% and divide it by 2, which is 2.5%, which is 0.025. Go to the calculator. You see there's some work involved. That's why I prefer to use a table here. 0.025 and put 15 and paste. You're going to get the -1. You just use the positive when you do the interval. There you go. So you use 2.131 as your TC. TC, by the way, for T, it's 3 decimal places, as you notice in the table. You want to check and see what the value is in the table if we didn't want to use the calculator. So remember, I did 95% and degrees of freedom is 16. Sample size is 17. Let's see, guys. So here's a 16 right here. And 95%, guys, watch. 2.120. Or 2.13. There you go. Match. Watch. If it doesn't match, I'm in trouble. 2.131. 2.131. So you can do either one. You can use the inverse T feature if you like. All right, next question. It's really a good one. Show you the power of confidence intervals. To help consumers assess the risks that they are taking, the Food and Drug Administration, FDA, published the amount of nicotine found in all commercial brands of cigarettes. A new cigarette has recently been marketed. The FDA tests on the cigarettes gave a mean nicotine contents of 26.1 milligrams and a standard deviation of 2.5 milligrams from a sample of N equals 9. So guys, this is X bar. This is S. Why S not sigma? Because he's using a sample. And this is N. He says already N equals 9. The FDA claims that the mean nicotine content exceeds 28.9 milligram of this brand of cigarettes. And they're saying it exceeds, this is the cutoff number. Cigarettes should not exceed this one, but the FDA, it says they have a nicotine on average of more than 28.9. And this is really bad news for the cigarettes company if they're not following the FDA guidelines. And the FDA uses a confidence interval of 90%. Do you agree with the FDA? Is their claim correct or not? What we're going to do, guys, to decide whether we agree or not, we're going to find a confidence interval because that's what you use. So let's see what confidence interval they found. And then I'm going to be asking you guys to tell me whether you agree or not. In order to find a confidence interval, you need a sample size. You need a sample mean. We're going to use the calculator now for this one right away. we're going to use a sample standard deviation, which is 2.9, and the 90% confidence interval. So let's use T interval on the calculator. And let's do it. And be prepared to answer the question whether you agree with the FDA or not. So we go to stat, tests, T interval, number 8 for this section, guys. Okay, no data yet. So X bar, what was X bar? I forgot, 26.1. Standard deviation is 2.9. Sample size is small, 9 cigarettes, and confidence level is 90. And here's the confidence interval, which is 24.3 and 27.9. All right. The FDA, guys, claims that the mean nicotine in this new brand of cigarettes exceeds means it's over 28.9 milligrams. If you were the company and you did the confidence interval, would you reply to the FDA and tell them that you're wrong, or you tell them that they were correct about their statement? What do you guys think?
That they're wrong.
Why they're wrong? Why the FDA claim is wrong?
Because the confidence level, the highest is only 27.9.
Very good, excellent observation. Look, guys, the FDA is saying that this company is exceeding 28.9 milligrams, and they use a 90% confidence interval. Well, we did a 90% confidence interval, and we found out that the mean cannot exceed 27.9. Look at the 27.9. So the FDA, we don't agree with the FDA. Their statement is wrong. They have to go back and look, just at their work. So that's how and that's very, very important. If you can do a study and show the FDA that the claim, because if the claim was correct, guys, that means we'll put, the cigarettes company out of business. But the claim, what the FDA states is not accurate based on our confidence interval. So we don't agree. Because the maximum value of the interval does not exceed 27.9. So you should not agree with the FDA, guys. I know it's a tough thing not to agree with the FDA, but based on the results here, we won't agree. And if you guys were to do this by hand, you could do it. If some students prefer to do the work by hand, but I wouldn't mind if you use, as I said, just technology. You would have to find TC, guys, first, which is you need 8. And why 8? Because you have to subtract 1 to get degrees of freedom, and 90%. And watch, guys, 90% is right here, and 8, it will be right there, 1.86. 1.860, so TC would be 1.860, and then E, guys, will be TC. That's the formula. I will provide those formulas always. So 1.86 times S, which is 2.9, and then divide by square root of 9. And let's see what the math says here. If you want to show you the work, I'm going to get the same interval that I got off the calculator. 1.86 times 2.9 divided by 3 will give me 1.80, And your interval, guys. Oh, this is where I used. Okay, so that's. We don't need this anymore. And the interval will be x bar is 26.1 minus the margin of error and 26.1 plus the margin of error, guys. And that will be mean is 24.3 and 27.9. And the decision, we don't agree. Because the largest value in the interval does not exceed 27.9. Okay. The FDA is saying it's more than 28.9. I don't have 28.9. I have 27.9, the maximum. So that's not true. Okay, for example 4, guys, I would like you to work on this example with me. So we're going to find a confidence interval, but the data is going to be given to us as a raw data, not a summary of the data. You see, you have data here. So the first thing, before even I do anything, I would like you to put this data in L1. Let's do that. I'll pause for a minute until you do that and then record. So let's go back to this question. The grade point average for 10 randomly selected junior college students are listed below. Assume that the grade point averages are normally distributed. He has to make this assumption because the sample size is less than 30. According to the central limit theorem, guys, if the sample size is less than 30, your distribution, it has to be bell-shaped. Find a 98% confidence interval for the true mean. Round to the nearest hundredth, 2 decimal places. And watch, guys, how we do this. You go to stat, tests, nothing different from what we did. T interval, oops, sorry. Enter. Okay. Anything I have to do here, guys, there's something you have to change now. Your input is not a summary that he gave you. Your input is data, so you have to switch to data and press enter. You see now it's asking you where the list is. You press second and number 1. Second, because I put it in 1 and number 1. By default, it should be L1 on your calculator. And confidence level, what does he want? A 90%? Let me see. 98%. So change this to 98. Any questions, guys? Just want to make sure you understand what I'm doing here. And then hit calculate. And here's the interval. He says 2 decimal places. So T interval mean is between 1.55 and 3.53. And he says interpret the interval in words. You say with 98% confidence. You can say that the true mean, when I say true, is the population mean. The true mean point average of junior college students is between, don't forget the word between in those intervals, 1.55 and 3.53. That is the GPA. Does that mean that the student on average are passing, guys, from this interval or no? What do you think? this is a large interval, as you guys can see. If a students have 1.7, it will be inside the interval. 1.7 is not passing because it's below 2. And if a students get 2.5, it's a passing, it's a C. And if a students have a 3.2, which is inside this interval, that will be a B. So this is a very, very large interval. And the reason why this interval is very wide, guys, because the sample size is small. When the sample size is small, you're going to get a large interval. So you won't get much out of it. And remember also the confidence level is very large as well. It's 98%. If I try to do a 90% confidence level, look what happens to the interval, guys. Watch. Second, and sorry, clear, stat, tests. And I'm going to go to number 8. It's number 8 on all calculators. And I'm just going to change this one to 90. But remember, now your confidence is not high as 98%. Your confidence is getting low. 1.89. So it's 1.9 and 3.2. 1.9 and 3.2. Still, it's a large interval because if a student get 1.95, he will not pass, so that's a D. And then, but you get a narrower interval as you decrease the confidence level. If I decrease this one to 80% confidence, but I don't think you'll have any questions with 80% confidence, guys, but let me show you what happens. Your interval is going to decrease. It's going to become narrower. Watch. But nobody trusts a study with 80% confidence. Everybody is passing. So you can say with 80% confidence, the true GPA is going to be between 2 and 3. That means nobody will fail, but your confidence level, you're not that confident with this information. You're only 80% confident. So that's the consequences of decreasing the confidence level. You can get a better interval, a smaller interval, but your confidence level is low. So, and that concludes section 6.2.